Okay, so the last video ended abruptly with one more anterior pituitary hormone to go, and that is the growth hormone. The growth hormone doesn't really have one target area. It's going lots of different places, but specifically bones, long bones. But it is going more than that. It is going anywhere that is stimulating mitosis and also cellular differentiation. So that means cells becoming different types of cells. So it's kind of going all over the place. So this talks just as an overview of all of those hormones that we just went through from the anterior pituitary, and it shows you where they are going. Exactly. So the growth hormone is growing to the liver and also to fat, muscle, and bone. So like I said, everywhere, all over the place. Okay, and then the posterior pituitary we talked about has two hormones that are straight from the hypothalamus. Those are oxytocin and ADH, and it stores those and then are going to be released. And that's when the hypothalamic neurons are stimulated. So antidiuretic hormone increases water retention, so that reduces the urine volume to prevent dehydration. It is also called vasopressin because it can cause vasoconstriction. And then oxytocin is the last posterior pituitary hormone. We can see this during certain times and promotes feelings of satisfaction and emotional bonding between partners. It can stimulate labor contractions during childbirth and the flow of milk during lactation, and then also the emotional bond between the lactating mother and the infant. So there's kind of a lot going on for oxytocin. I would encourage you to watch through that. So how are these pituitary hormones controlled, and why are they not just secreting all the time? Well, they're not. Luckily, they are not secreting all the time. The secretion is not constant. It is regulated by the hypothalamus, and then other brain centers and feedback from target organs. So again, this is going to be different for the different hormones, but giving an example, so the anterior lobe is going to be controlled by the hypothalamus, releasing hormones or inhibiting hormones. So an example would be in cold weather, the hypothalamus is going to stimulate the pituitary to release more TSH to generate body heat. So an example of one that has cerebral control is if we are talking about milk. If we have an infant, that stimulates the nerve endings in the mammary gland, and then that sends the message to the hypothalamus and then to the posterior lobe, and that secretes oxytocin, which prompts the milk to be ejected. And so all of this is, again, we're not going to be able to go through examples for each one, but you can see that the kind of the product of that milk coming out is really comes from a stimulus. And so usually we talk about these stimulus has to do with negative feedback, but there is one example of positive feedback. And again, you should have had this in the very beginning of AMP1, but I know it's been a long time. So negative feedback means that increased target organ hormones inhibits the release of more hormones. You can think about negative feedback like a thermostat. So as the hormone levels rise, then it kind of shuts off the release of more of those hormones. Whereas positive feedback, the stretching of the uterus can increase oxytocin release. That causes contraction, causing more stretching of the uterus until delivery. So in that example, positive feedback is where more of the hormone triggers more of the response to make more of the hormone. Okay, this goes into a little bit more detail about growth hormone because it's kind of going lots of different places and it doesn't have such a simple target. It has widespread effects on body tissues, cartilage, bone, muscle, and fat. It does induce the liver to produce growth stimulants. So it is not the only thing doing all of those. Insulin-like growth factors 1 and 2. So that's why the liver was on that picture. I'm not picky that you know about the half-life of these hormones. That is going into too much detail for me. I think memorizing the ones that we need to memorize is going to be plenty for us to do this week. Just a little bit more about growth hormone, we know that bone growth and thickening and remodeling are occurring, especially during childhood and adolescence. Those also have to do with growth hormone. It is a high secretion during the first 2 hours of sleep and can peak in response to vigorous exercise. And normally the growth hormone levels are going to decline gradually with age. So gives some numbers to that. So 6 nanograms during adolescence is down to 1.5 in old age. And then that gives you kind of the composition of bone, muscle, and fat at 30. And then as we move towards 75, how it changes.